thank you for joining me today. Today we're going to be taking a look at the perimeter protection and thermal solution from Hikvision. My name's Nathan Garner. I'm the project manager and one of the tech support team leaders here at Dynamic CCTV. What we're going to do is going to go through some slides, just giving a bit of theory background to the thermal cameras that are available from Hikvision, and then we'll do a live demo of the VCA rules, and then we'll move on to the fire detection and temperature measurement solutions as well. If you have any questions as we're going through the webinar, if you put them in the Q&A section, and towards the end, I'll go through those questions that are in there and answer them on the webinar. So what is thermal? So generally with standard optical cameras, it's looking at the visible light spectrum, and with thermal cameras, they're looking for infrared light instead. So any object with a temperature above absolute zero, which is minus 273 degrees Celsius, can emit a detectable amount of thermal radiation, and the higher the object temperature, the more infrared radiation is emitted from that actual object. So that's what the thermal cameras are actually looking for those. So this is how the actual thermal camera does what it does. So the thermal radiation from the object that it's looking at then hits the germanium lens on the front of the camera, and that will filter out all the visible light and only allow infrared light through the actual lens, and then it goes through the infrared focal plane array, and that is what actually generates the thermal image through the ISP and the SOC, and then you get the video stream from the actual camera itself. And this is where the VCAs will come in, which we'll show later on through there as well. So this is a thermal camera looking at hot and cold glass. So the way they actually displays, on the left is the hot water, and on the right is the darker image and showing near enough black on the screen. That is the cold water. So the hotter the object is, the more thermal radiation that it's actually giving out from that object. So the brighter that it's actually showing on the screen itself. There is a difference in materials depending on what kind of object that you're looking at. And so the difference between kind of duct tape and aluminium tape, you can see the duct tape's showing hotter than the actual aluminium tape is. So this is to do with the reflection and absorption of the infrared radiation from the actual camera. So with this comes into the emissivity ratings of different materials, which we do have a table for in a couple of slides, which will go through that. Depending on the type of material the camera's looking at can read differently, and that's why we have the emissivity settings within the web front end of the cameras, so this can be taken into account to make them more accurate when they're looking at the actual temperatures for them. So in order to use the thermal cameras, we use something called the emissivity rating of materials. This depends on the actual material that something's made out of, to whether or not it's wood, metal, brick or anything like that. It all has different emissivity ratings, and this is the amount of effectiveness of which the actual surface emits the radiation. So this needs to be taken into account when actually using thermal cameras. If it's not, then it can affect the accuracy of the temperature readings, and you can also get reflected temperatures as well. So if you're looking at a surface such as a plane of glass and there's a hot object near that plane of glass, if the thermal camera is pointing at the glass pane, you'll actually see reflection of the temperature. It's the way that the actual reflection's working with the radiation there. So these are the different emissivity values. So this is just a table that we've put in there, but I will send a copy out of the slides after the webinar, so you do have all these emissivity ratings to hand for when you're doing your own installs with the cameras. And you can also contact us here at Dynamic CCTV for the list as well. So the different materials, so we've got woods, rubbers, plastic, PVC, even human skin, they all have their own different emissivity ratings. The top ones are generally the higher emissivity, and the low emissivity values are the likes of copper, steel, different kind of metals there. The actual emissivity can vary depending on the roughness of the surface and the actual shape, if there's any holes or cavities in the actual object, and the viewing angle of the camera itself with the object, and also the oxidization of the metal, and also the temperature itself. So there is quite a lot of different things to take into account. Emissivity ratings are just a base level, but you best check them with a thermologist for the most accurate kind of setup with the thermal cameras, especially when needing high degrees of accuracy, the temperature measurements and temperature differences for them. What we can see there is the differences between the optical and thermal images. So on the left, we've got a standard optical image with some visible light in the area, so you can see it's still in day mode. And on the right hand side, we do have a thermal image. So on the left hand camera, you can see that there as time's moving on, but we can't really see anyone in the actual scene. You can just see up there where the white light is showing on the torch. There is actually a person there. If we look at the same scene with a thermal camera, we'll be able to see much clearly that there is actually a person in the field, and it's much more visible due to the radiation that that person is giving off. It makes it really clear to see on the thermal camera, which is great at longer distances or with nighttime images. You do get a much better image and makes it a lot clearer to see when there is a person there. Obviously these are much more low resolution than standard optical images, so you don't get the clarity as such in the image or the sharpness, but it does allow you to be able to detect when someone is there or whether or not it's a vehicle with these cameras much easily than you could with an optical image in some scenarios for them. So this is just another demonstration. So this is with visible and thermal images at night. So you can see a lot of the areas covered by bushes, and the thermal in the optical image, and I'm struggling to see the actual person, but in the thermal image, when they're over in the right hand side, it's much clearer for us to see, even though they are in the bushes, that we can actually see them on the actual thermal image better than we could on the optical image. So it makes it a lot better for kind of these scenarios for the actual system. With the thermal cameras, we generally recommend them for, especially on perimeter guarding. So if you've got a long perimeter fence line and you're needing to see anyone that crosses line crossing VCA, for example, if they jump over the fence or if they breach the perimeter. With standard optical images, it's very difficult to get your longer range detections. So you can see there at 250 meters, you can't really see the person that's in there, so you wouldn't be able to get an accurate reading with standard VCA rules on optical images for cameras. However, with the thermal cameras, they're designed to handle much longer detection distances, so you can see there on the actual camera image, even though the person's 250 meters away, and we can still detect them when they cross that line. So it makes it really good for use with perimeter protection, and we do have quite a few customers that have installed these on the likes of solar farms, where they need accurate detections and have really long perimeter fence lines, and the thermal solution works as the best kind of detection method for that, rather than the standard optical images that you'd usually use. So there's quite a few different applications that can be used for thermal cameras. So we've got our perimeter protection or perimeter defense, which we're going to move on to shortly, and which we'll be also showing a demo for with a camera that we've got fitted on the back of our building. But these give you the best options when there's poor lighting or need larger distance coverage. So if you're looking down a long fence line, and also if you're needing high accuracy on the detections. So with the thermal cameras on the VCA rules, such as line crossing and intrusion detection, not only does the object have to be given off a thermal heat source, they also have to comply with the algorithms. So it is deep learning, so you can set it to trigger off vehicle and or human. So it will also filter out animals as well on the actual cameras. You can also do temperature measurement. So with this, you can use the thermal cameras to measure a specific spot that you've set up on the camera and monitor that temperature using the actual thermal cameras. And you can also have it trigger an alarm when the temperature exceeds a specific threshold that you have set on the actual camera for the temperature measurement solution. There is also the fire source detection. So with this, the actual cameras can be put in fire detection mode and they can trigger an alarm when a fire is detected. There's also smoke detection as well, so it can actually detect sooner with those. With open areas such as fields or where you've got longer kind of grassy areas, thermal cameras can be used to help locate people in total darkness. And especially if there isn't a wide area. You can't cover a whole area in IR without using multiple IR lamps. However, with thermal cameras, you can cover a wide area and be able to see that person, help locate them using the heat detection through the actual thermal cameras, which makes it a good usage scenario for sites that need that kind of monitoring from their operators as well. So this is the perimeter protection. So this is using the deep in mind or deep learning algorithms within the thermal cameras. So you can see on this video here, we've got a bird that's actually jumped up and gone across the perimeter, or the line crossing, should I say, that's being configured, and it hasn't actually detected them. You can see the green box around them, that's just mapping the movement on screen as an object, but it hasn't classified them as triggering the alarm because it is set to trigger on humans only. So it has filtered out that on there. It's also another area showing the leaves, which is something that can trigger on standard optical images, but you can see there they're blowing across the actual line crossing detection, and it's not actually triggering the line crossing event at all. That's because there's no thermal radiation given off the leaves of the tree, and the learning algorithm isn't triggering it as a human on the actual event as well. So it's filtering those alarms out, which is especially important for monitored sites when you're using monitoring stations that do charge for false alarms that have come through. These are great kinds of scenarios and saves a lot of time without having alarms come through from these kinds of scenarios. We've also got the strange gestures. So even though people are crouched down, it will actually still trigger the areas. So it knows that they're actual humans, even if they're trying to fool it by doing different kind of gestures or different kind of stances. It will actually still trigger the events on the thermal cameras, so they can't trick the actual or falsify the alarm and prevent it from triggering, which is a extremely powerful kind of solution. The algorithm's smart enough to know that with the system. So this is another thermal camera that's been configured with intrusion detection, which you can see on the actual system there for that. So you can see it's set to the vehicle scenarios, so it's not picking up the actual vehicles on there, it's only picking up on human. So even though there's vehicles and cars driving through, it's only actually triggering on persons as they enter the intrusion zone. So you can have it looking at a roadway, passing by vehicles wouldn't trigger the actual VCA, but if any humans enter that area, then that would trigger the alerts from the thermal camera on there. So this is the configuration for the target types on the VCA rules. So you can see we've got intrusion screenshot there. So we can actually go in and set the detection target to be human and or vehicle. And these work at up to 95% accuracy with the newer algorithms as a filtering, which is a lot higher than the standard optical images using deep in mind algorithms. So you do get that more reliable results from your actual detections from the VCA rules on the thermal cameras than you do with the optical images on those. So this is BMW car shop in Europe. So you can see there the need to see when a human is entering the premises, and they do have vehicles that are parked up. So this intrusion and line crossing system has been set up to only trigger off humans. So it's not detecting on the vehicles, but when a human crosses the zone, it will actually trigger the event on the system for that, which makes it a great solution for these kind of sites where there's vehicles parked up, or there's going to be vehicles going through, and you only want to see when a person's actually triggering that event on the system. So there's a few different resolutions that are available in the thermal ranges. So you've got the high end for your higher end solutions where you're needing the extra resolution in the image. You've got your medium range and then your eco range, which is the lowest resolution on the thermal images. Depending on the scenario that you're needing, so a lot of the times you can use the eco ranges, but if you're needing higher accuracy or longer distances, and then you need to start looking at the higher end, higher resolution thermal cameras, and depending on the scenario. But we can help you here at Dynamic CCTV to kind of match up what product matches the scenario that you're looking at with your clients for that, which we're happy to help there here at Dynamic. So these are just a few of the different ranges with the thermal cameras. So you've got the Performance series, which are bi-spectrum, so these can be turrets and bullet cameras. You've also got your Special series, such as the anti-corrosion units or the explosion-proof thermal cameras. There's also the positioning systems. These offer some of the highest, or should I just say, longest distance thermal detection, with some of these reaching up to 1 kilometre distance from the actual camera itself. You can detect a human and or vehicle 1 kilometre away from the actual camera position, which makes it really powerful, and even on your longest perimeters would be able to help put a solution together for you on there, depending on what's needed for the site for those. And then this is just the actual VCA detection distances. And so at the lowest end range, you've got your kind of 20 metre detection distances from the cameras, and then you move up into the next range, which is your 70 metre distances, which is your 384 and your 640 resolutions, and they can go all the way up to your 1 kilometre detection distances for the thermal cameras. And so this is specifically for the VCA rule detections for the different cameras that are available on the thermal side of things. So these are the different cameras that you can use for the perimeter detection. So you can see on the left hand side, these are kind of the eco ranges, and so these work between 21 metres up to 70 metres, and they also have the smoking detection, perimeter detection, fire detection, and the deep learning algorithms. But depending on the accuracy that you're needing, there is also the thermography, or should I say thermometric range of thermal cameras that are available for your higher, more accurate temperature readings, because this range perimeter detection works at an accuracy of plus or minus 8 degrees Celsius. We've also got the longer range bullet cameras, so these go from 100 metres up to 1 kilometre detection distance, depending on the camera model that you go for. And there's also the positioning series that are available, which can actually go up to 1.8 kilometres on some of the largest units that are available from the thermal range for those. So what I can do is I can bring up the web front end of our thermal camera that we've got mounted on the rear of the building. I'll just drag that over now. So this is the web front end of the thermal camera itself. So standard kind of web front end, standard design that you'll be familiar with from standard cameras. If we go into the configuration page, go into our system, and so this is the 2617-3/V1. This is a 3mm lens thermal camera that we're using for this demo today. So normally if we were setting up intrusion detection or line crossing detection on a standard camera, we'd go into our event section and go into our smart events. But with the thermal cameras, we actually do it through the VCA menu in the web front end of the camera, which you can see there just on the left hand side of the settings. So firstly, we've got the basic settings for the VCA rules. So this is the intelligent analysis and also the display VCA rules on the stream from the camera. So this actually allows us to see the rules displayed on the live view of the camera. The trajectory, so this will actually map the person's path or the vehicle's path that they're taking through the actual camera image from those which we've enabled on the system. And then the most important part is for the calibration for the actual camera. So what this does is this sets the sizes that are required for the system. So when you first install a camera, you need to go into camera calibration, and then there's two different calibration types. You've got the auto calibrate and you've got a manual calibration. And for this setup, I configured this using the auto calibrate option. So you'd put in the person that's going to be walk testing it or walking through the area to calibrate. So you'd put in the person's actual height, so that would be your target height that would be entered in here, and then you kind of walk around the actual area of the camera in a figure of 8 while it's recording, and you'll get, once saved and the calibration has succeeded, you'll get these 4 areas that have been taken by the camera, and it uses that for the actual calibration of for the VCA rules, which increases the accuracy and helps with all the false alarms from the actual cameras. We've also set up a shield region on this camera, and so at the top of our camera image, there are some hot zones that are out there due to the factories that are behind our building. We do have vehicles going through here, so I have shielded this region off just so we don't get any thermal detection showing on the screen, just to make it neater for the actual webinar. And then if I go into the rule section, we've actually got the line crossing rule that I've already set up this morning for the area. So you can see we've got our max and minimum sizes set. So this is filtering by pixel size on the camera. And we've got our detection target set to human and vehicle for this one. What I can do is I can go in, I can click on the add icon there, and I can create a second rule for the actual thermal camera. So for this one, I'm going to set up an intrusion detection. So I'm going to set this to be 5 seconds, and I'm also going to set our filter sizes. So this is the maximum size an object can be to trigger our intrusion zone. So mine's only going to be working off humans, and I know how big they're going to display on the camera as you go through. So I'm just going to set my maximum and minimum sizes. So the maximum size is the largest an object can be, or that you want to be able to detect. Sometimes it's the best way to do this is to do a walk test. So if you're just using humans, you'd have persons stood as close as the camera would work for the detection, and that would kind of be the maximum size they could display on the camera image. And then your minimum size would be your maximum distance of a person that would trigger the actual rule for there. And that makes it most accurate it can be for the actual setup of it. The duration, so this is the time in seconds that person needs to be within the intrusion zone before the actual alarm will actually trigger on the system. And the sensitivity, we've left that at 50, and we've set our detection target. As there's no way that any vehicles can get down to this area, I'm going to set this to human. And then I can click on the hexagon there, and I can start drawing the area. So I'm just going to draw this area over here for that. So that's my intrusion zone that I've drawn for the thermal camera now. And if I can click save, that's now set that intrusion zone on the camera. So I've got a line crossing and an intrusion detection set up on the same thermal image. Now, in order to be able to have the events to go through to the likes of IMS 4200 or the Hikvision VMS, and or even emails as well for monitoring stations, we can go into the alarm linkage section, and we can have different linkages depending on the VCA rules. So we can upload to memory card or an FTP server, and we can also set it to trigger an email if we wanted to as well. And the thermal cameras also have physical alarm outputs on the fly leads, so you can trigger those directly from the camera depending on what's needed for the site. So this could be lights, or they could trigger an alarm siren from a VCA being triggered on the camera. And then our arming schedule, just got this set to continuous for this demo here. And then in the advanced configuration, these are if we want to change the detection parameters. Generally, there isn't a need to change these, but if there is, we'd advise on that. If there was any issues on site, or if it's just something that needs tweaking slightly, our tech teams will assist with that on site. And what I'll do is I'll just ask my colleague to get ready to trigger the event. If I switch this over to the live view for the camera, I'll just ask my colleague to go down. So my colleague's just on his way downstairs now to trigger the detection zones that we've set up. So the thermal camera that I'm using today is a bispectrum camera. So it has both an optical image and a thermal image. So we've got our standard kind of optical image that can be used for visual verification on the left-hand side. And then we've got our thermal image on the right-hand side of the image there as well. And my colleague should be there any second now. And he's going to walk out into this area and come across the scene. And you can see the camera's mapping him and also tracking his trajectory. And you can see there he's actually triggered the line crossing, but he hasn't triggered the intrusion zone because of the time settings that we actually set up on the intrusion zone. And as he walks back through, it's mapped him again through the actual system there for it. So it can actually map the trajectory of a person as it walks through the actual zone, and also do the same with vehicles. So we'll track the trajectories of vehicles as well with the thermal cameras on there. If I switch back to my slideshow there. So now we can take a quick look through the temperature measurement and fire detection that's available with the thermal cameras. So on the thermometric range of thermal cameras, these are your more accurate thermal cameras that are needed for the likes of looking at motors or machinery, where you need an accurate reading on the temperatures that they're being detected as. These can work at an accuracy of plus or minus 2 degrees Celsius, and this is great for when the temperature difference between the temperatures that you're measuring is quite small. These are the higher end kind of cameras that you'd need to use in those kinds of scenarios. So the image technologies that are used, you've got the adaptive AGC. So this is more flexible environment with more layered image. And then in the DDE, you can see the difference between the images with the technology turned off and with the technology turned on. There is also within the bispectrum cameras the ability to use image fusion. So with standard thermal cameras, we know that the resolution is quite low, so you don't get the sharpness in the image as there's less resolution to work with. So what the Hikvision cameras have is the ability to use image fusion, which will allow you to use the optical image to increase the sharpness of the actual image, thermal image, to make it a lot sharper, so you can see some of the other objects in there that's been overlaid by the optical sensor in the camera, which makes it a lot easier to look at, a lot more useful as a scenario for that as well. So with the temperature measurement, we can configure a temperature exception alarm. So this is a kettle that's boiling in the video, and when it gets to a specific temperature that's been set on the actual camera, it will trigger an alarm. So at the moment it's in its warning state, and then when it turns to red, that's when the actual alarm's triggered. So it was set to trigger at that temperature for the camera. And these can work up to 550 degrees C and work all the way down to minus 20 degrees C. So you can set your temperature exception alarm depending on what's needed for the site, and which is great for monitoring any kind of machinery, stuff like that. You just have to take into account your emissivity ratings to set those up correctly, depending on the material that the camera's looking at, to make it as accurate as possible for the solution that you're using it for on site. So this is temperature exception alarm for fire prevention. So first the temperature of the object increases, then the object starts to smoke, and then the fire starts. So with the thermal cameras, you can use it to detect the actual temperature increasing or going above the temperature that you've set for the alarm event on the camera. So it can be used as an early warning and detection system, which can make it much easier and much quicker to be able to detect any issues or prevent any fires from occurring on site for those, which can help out for that and make it a lot easier. We have used these on waste dump sites where they're needing to monitor the temperatures of the waste piles for those. So it makes them a really powerful solution, makes it great for an early warning detection system, but they're not designed to replace normal fire detection systems such as fire alarms. These are meant to be used in conjunction with, not to replace. So we've also got the smoking detection in the cameras. These cameras can detect whether or not smoke's detected, so the hot cup and the lighter won't trigger. And these can work at varying distances depending on the lens of the camera. And so the 2mm lens would work at 2 meters, 3mm would work at 3 meters, and a 6mm lens would work at 6 meter detection distances. And this is just a demo of trash site in Slovenia, which is actually monitoring different areas with the temperatures. So you can see we've got different piles of rubbish with different thresholds configured and set on the camera. So depending on the temperature increases, these will trigger when the temperatures exceed a certain level that has been configured when the site was commissioned for this. So that's a quick look at the thermal cameras that are available from Hikvision. There is a powerful tool that we do use quite a lot when we're designing for helping design projects with customers, Hikvision Thermal Design Tool, which there will be a link to when I send the slides out, just on the left-hand side there, and that will take you to download the actual tool, which can be used on desktop. So this allows you to be able to import a map into the design software and set a scale, so you can more accurately put together a solution, for example, for perimeter protection with a fence line. As long as you're able to set the scale for the actual map within the design tool, you'll be able to build up a design for the site, and it will also allow you to export a full design report with the different model numbers of the cameras that you've put in, the different mounting heights and even the mounting angles, in order to be able to get the detections that you are wanting for the site. And it will also allow you to do this for the temperature measurement and fire detection, and it will give you the different coverages, so greens for the VCA rules within that, so it'll give you the actual working distances of the cameras depending on which ones you put into the tool for your design. So the final thing to just wanting to mention our technical support team. And so here at Dynamic CCTV, our tech support is available Monday to Friday from 8:30 till 5:30, and on Friday we close at 5 p.m. We do have 10 technical support team members that are available to take your calls. We don't have a queuing or ticketing system. When you ring our technical support line, one of our highly trained technical support team will answer the call and be able to assist with any issues that should arise or any questions that you may have. And also we do have our posts done on our social media channels, our LinkedIn and YouTube channels. We do post quite frequently helpful how-to videos, demo videos of new technologies, and also the recorded versions of any of our webinars are all uploaded to our YouTube channel, and these are all clickable links that you'll be able to click through when you email out the PDF version of the slides. And we also have our technical news bulletins, so if you want to keep up to date with the latest technologies that release, the latest firmwares, and or any new videos that we post, please sign up to our email tech support bulletin just on our website, and so also be a link on this slideshow once I send this out as well. So thank you for joining me today. If you have any questions, please put them in the Q&A section. I'll start going through the ones that are already in there. Alternatively, you can contact me using my contact details on the screen there. I'll be happy to help with any questions that you may have. If you want to speak to our sales team for any pricing, please give us a call on our main office number, or speak to your Dynamic CCTV Business Development Manager, and they'd be happy to help with those. So I'll go through these now. So Nigel has asked, can you use thermal cameras to protect livestock in fields without lots of false alarms? So you could set the cameras to be human detection only, so it will filter out the animals that are triggering. Generally, you'd use this on a fence line as well for the system, so if anyone crosses the fence, they would then trigger as they're a human on the system, and then the cameras would filter out the animals that walk through that line across an area, or intrusion detection for those ones. And Nigel's also asked, could I use a bispectrum camera with the thermal alerting for fire and the optical feed being processed deep in mind to look for intruders? So in theory you could do that, but generally it would be less accurate than using a standard thermal camera with the alerts going through for your VCA rules. But in theory you could add the optical image from the camera, as they are two separate streams. You could actually add that optical image to a deep in mind MVR and have that set up for your standard line crossing intrusion detection with the deep in mind MVR. Just you wouldn't be able to enable it on the camera itself, as the resources would be directed to the fire detection, and it would probably be best off using a separate camera for that kind of scenario for that. Any other questions come through? Could you use the thermal cameras to detect leaks, both hot and cold? And so you can use it to trigger off a temperature drop or temperature increase for those with the thermal cameras, because you'd set your temperature thresholds with the system. That is possible with the thermal cameras on there. I think that's all the questions answered. If there is any that I haven't answered, I will send out an email response to those. And if you have any more questions, please feel free to contact me on my details on the screen there, or speak to our technical support team or your BDM for your area. So thank you for joining me today. I hope you've enjoyed the webinar and found it useful. We do have some more that are going to be scheduled for next month, which we will be sharing online soon and posting on our social media channels. And the recorded version of this webinar should be posted towards the beginning of next week, and I will send out an email with all the slides on after this webinar. So thanks for joining me. Take care, stay safe, and I'll see you on the next webinar. Thanks, bye.